Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to identify the number of significant figures in various kinds of measurements or numbers that you are given. So the thing to keep in mind when you're thinking about significant figures is that significant figures are due to the measurements that you're making using a particular kind of instrument. And the instrument has a certain amount of uncertainty in it, or precision, if you will. So depending on the precision of the instrument, you can only get a certain number of digits from your instrument in your measurement. And so, one of the other things you want to keep in mind is things like counting numbers. Something that is not a measurement is not going to have a certain number of sig figs. Actually, it's going to have an infinite number of sig figs because it would be an exact number. So, counting numbers are exact. Anything that's exact is going to have an infinite number of significant figures. So, for example, if you're counting the number of marbles in a bag or the number of students in a room or whatever, that's not a measurement. You just count 1, 2, 3, 4, 5. You're not measuring the number of people in a room, right? Or you're not measuring the number of marbles in a bag. So there is no limit to the significant figures because it's an exact number. So here are some examples I want to go over. But before we go on, please remember, if you like this video, please like, share, and subscribe to my channel. Hit the like button also, and put a comment in the comment section. So without any further ado, let's get into this. So for A, you're given a book contains more than 1,000 pages. So 1,000 pages, um, that's a counting number. You don't measure the number of pages, you count them. Normally, you would count them. Um, so, so in this case, this would be an exact number. So this would have an infinite number of sig figs. So let me use a different color here. So this would be infinite, right? So an infinite number of significant figures, that would be an exact number. But let's for the sake of argument, if we were like look at this number and say, okay, let's say it was a measure. How many sig figs would that number have? Well, one of the rules that you're thinking about is, what do we do about these zeros at the end of a number? And the rule for that is, if there is a decimal point, then you count the number of zeros as significant. If there is no decimal point, you don't count the zeros. That's one way to look at it. Some books, some teachers, some professors will say, well, it's ambiguous, right? So you don't know what the number of sig figs there is. But a lot of books will say you don't count them if there's no significant if there's no decimal point. So the rule is, for zeros at the end, zeros to the right of your number here, zeros to the right are only significant if there is a decimal point. We don't have a decimal point here, so if we were to count the number of sig figs here, assuming this is a measure, there would be only one significant figure, because that one there, the zeros would not be significant. But because this is a counting number, you're counting the number of pages, it's actually infinite. What about this? You have a mile is about 300 or 500, 5,300 feet. Okay, so here the key word is about, right? So it's not exact. So if this is the number that we're given, notice that this would be a measure um, for this. So given this number here, notice there's no decimal point. We have the zeros to the right of your number, at the very end of your number. They also call these trailing zeros. So these zeros here are only significant if there's a decimal point. Notice there's no decimal point, so therefore they're not significant. So the only digits we would count is 5 and 3. So this would be two significant figures. So the number of sig figs would be 2. What about C? a liter is equivalent to 1.059 quarts. So one of the things that says equivalent to, this is actually a measure. How do I know that this, oops, excuse me. So how do I know if this is a measure or if this is equal? So here we have liter. Liter is a metric unit, and quart is an English unit. Whenever you have an English unit being compared with a metric unit, whenever you're comparing those two different systems, you've got a measurement. It's not exact. So you need to count significant figures. So in this case here, this number, uh, again, we have our measurement here. And so if this would be the zero here, the zero, the other rule or another rule for sig figs regarding the zero in the middle, whenever you have a zero that's in the middle or sandwiched between two non-zero numbers, the rule is that those zeros are always significant. So whenever you have a zero that's sandwiched between two non-zero numbers, it's significant, always significant. So in this case, we have a 1 and a 5, and the zeros between the 1 and the 5, so that is significant. So in this case, we have the 1, the 0, the 5, the 9, so that's going to be 4 significant figures, 4. Okay, so the number of sig figs here. Oh, here, again, if this was a measurement, if we're just going to look at this number and say, well, how many sig figs would be there if I didn't know there were pages, we said it would be only one sig fig there. But if we're counting pages, then that is an exact number. So it's infinite number of sig figs. All right, what about D? The population of the U.S. is approaching this many million people, right? Um, the great thing about scientific notation is whenever they give you a number in scientific notation, any digits that are here, whether they're zeros or not, are automatically significant. Because that's the great thing about scientific notation is that when you write them in scientific notation, the number of sig figs is accounted for. So here we have a 3 and a 5, so that would be two significant figures. We don't care about the superscript here. The power of 10 does not affect the number of significant figures. It's only these numbers here. If this was, for example, 3.0 times 10 to the 2 million, right? It would still be two significant figures because that zero is significant because it's part of the scientific notation. It's given to you in scientific notation. Also, you notice there's a decimal point there. So again, you could also follow the rule that zeros to the right at the end of your number, those trailing zeros, those are significant when there's a decimal point. We have a decimal point, therefore significant. So that's another way to think about it as well. So this is 2 sig figs. For E, a kilogram is 1,000 grams. So here we have a metric compared to a metric unit. And so whenever you have a metric to a metric or English to an English, whenever you're comparing the two units in the same system, in the same category, right? So mass unit to mass unit, volume unit to volume unit, if they're in the same category and they're in the same system, metric to metric or English to English, that's going to be an exact relationship. That's going to be true by definition. So 1 kilogram is equal to 1,000 grams by definition. So it's exact. So technically, this has an infinite number of significant figures. So this is an infinite number of significant figures. But if we were going to, if we didn't know that this was exact and we are like going to figure out the number of sig figs, again, it would be only one sig fig because there's no decimal point there. So therefore, these zeros would not be significant. But in this case, this is an exact number, so you got an infinite number of sig figs. All right, and last, the Boeing 747 travels at around 600 miles per hour. So this is a measure. It's not exact. And again, you'll notice there's no decimal point there. So this would be only one sig fig. The 6 is the only one that's significant. The zeros are not significant because there's no decimal point. If there was a decimal point, if you have a decimal point there, then those zeros would be significant and you would have 3 sig figs. But since we don't have a decimal point there, then it's only one significant figure. So that's significant figures. That's how you can figure out whether you have one or two significant figures or an infinite number of significant figures. I hope this video is helpful. If you like this video, please hit the like button, share the video with your friends. Put a comment in the comment section. Let me know what you think or if you have any other questions. And subscribe to the channel. Thank you very much for joining me and have a great day.